equal chords of a circle or of congruent circles are equidistant from the center or centers. So what does the theorem tell? The theorem is telling this. I have two equal chords. Something like this. So this is the center. The distance from the center means what? A perpendicular line. And this perpendicular line. Their length is one and the same. I have a chord AB and PQ. So we have the center O, and this are, remember, perpendicular line. We'll call this as T and this as E. So we have to prove that OT is equal to OE. I mean, that's what the theorem tells. Let's prove this. Right? So what do we have? We have a circle with center O. Let's consider, okay, I'll start over here. Let's consider a circle with center O. Let AB, comma PQ be two equal chords. Let OT and OE be the perpendicular distance from the center to OT is perpendicular to PQ, comma AB and AB respectively. Now, what is that we need to prove? We need to prove that OT is equal to OE. Now let's look into the proof. How will we prove this? Again, we need to go back to, I'll give you guys a clue. This. Do you know what is this? What is that I'm talking about? Yes, congruency. We need to prove that these two triangles are congruent. I'll give you guys one more clue. Let AB, which is equal to PQ, be equal to 2x. That's your clue. I hope you guys try to think over how to go over doing this. So let's look into this now. So I took AB and PQ as 2x. Okay, then I'll tell, therefore QT will be equal to x and EB will also be equal to x. Why is it so? The reason is quite simple, because a perpendicular from the center of a circle to a chord bisects the chord, right? So basically OT will be equal to half of AB and EB is equal to half of, actually I should write that first. Let me write in a particular order. QT is equal to half of PQ by 2, which is equal to x, and we have EB, which is equal to half of AB, and so even that will be equal to x, right? So that's your reasoning. Now what is the next thing? So I proved that this is equal to this, so this length is equal to this length because both are equal to x. Then OB is equal to OQ. Reason? Because they are radius. Then what else? Then we have angle OTQ, which is equal to angle OEB, because they are equal to 90 degree, as OT is perpendicular to PQ and OE is perpendicular to AB. Then with all of this put together, therefore by RHS, right angle, hypotenuse and a side, congruency, triangle OTQ is congruent to triangle OEB. Okay, and since these two lengths are equal, these two triangles are congruent, therefore OE is equal to OT by CP/CT, and we have the proof. Right, so this is your proof. I hope you guys understood the theorem. If you have two chords of equal length, the distance from the center will be equal. That's what we had to prove.